Hola, ¿cómo están? Bienvenidos a Encuentros del Futuro, el programa de entrevista del Congreso Futuro. El día de hoy estamos con dos importantes invitados. Ambos nos van a hablar del espacio y otras cosas. Professor Catherine Jean Cesarski, you are a PhD in astrophysics at Harvard University, a former director of the European Southern Observatory.
Yes.
And Professor Brian Schmidt, who got his PhD also in the Harvard University. He won the Nobel Prize of Physics of the year 2011 for the discovery of the accelerated expansion of the universe through observation of distant supernovae. Is that correct, Professor?
That is correct.
Great. Okay, let's begin. For both of you, think about this question. How important is empathy to create successful team of work in science? I leave it to you.
I think we both care about that.
Yes.
You really we know each other pretty well. And I think you here took two people who really care about empathy in a team. And I think it's indeed absolutely important. And we astronomers have a fantastic life because we have this fantastic job. And we try to create, and usually succeed, very nice relationships with all the people we work with.
And if you think about it, when you do, let's just take my work that I did to discover the accelerating universe. That was a team of 20 people. And to get 20 people to work for 3 years, very hard, you have to have empathy for what's going on in people's lives, how they see the world, how we can share what's going on, so everyone feels part of the program. That's how you get things done. And without empathy, then you could just be hiring a contractor out on the street and go to the highest bidder. That's not the way science works. It works by passion. Mm-hmm. It's not just a job.
Professor, you said that this is a fantastic job. Give me some ideas. Why to be astronomer? It is a fantastic job.
Because we wake up in the morning and our main worry is not whether there will be a traffic jam and will I get a raise. Of course, we care also about such things a bit, but it's not by all means what we care most about. So we wake up in the morning and we think, has this observation done well? Or is there a new result that I care about? And we rush to see the new results, or we go to a talk. And at least for me, but I think for many of us, except for the family, of course, which is extremely important, all these worries that I share with everybody are below, So that's so lucky.
You also think that it's a fantastic job to be an astronomer?
It is. It's a great job because, as I said earlier, you're a scientist or an astronomer because you have passion for what you do. Most of us could get a job in industry that would be simpler and probably pay as well or better with equal amounts of certainty. But as a scientist, you're out trying to unlock the secrets of the universe. And it's hard, but it's fun, and it's quite empowering to be able to go out and learn things no one has ever known before, and then share them. It's a huge privilege. And so it is not just your ordinary job. It is a very special job that I think each of us see us as being privileged to have.
Good. Let me give you 3 possibilities. Titan, Europe, or Mars. Which one is the best candidate to find alien life outside of planet?
Europe.
Europa. To me, yep.
Yeah, both.
So,
and why?
If it's Europa, Europe, I promise you, already has life.
Okay.
But Europa, the moon, has a liquid, we presume, water ocean on it. And we know that's where life started on Earth, as near as we can tell. And the fact that there is a water, liquid form ocean in our solar system that's probably been in existence for billions of years, that's exactly the place you might expect life to form. It's a beautiful place. And so compared to Titan, which has to have some different type of chemistry we don't even know exists because it's methane-based, really cold, And Mars, which is okay, just much more hostile, maybe had liquid oceans in the past, not clear that it has now. That's why I like Europa the best.
You also, Professor?
Mars is a very serious contender for having had life in the past.
Okay.
And so the search that is taking place now, and there are big efforts. First of all, you have landers on Mars, and then you have in preparation missions that will even bring pieces of Mars back to the Earth. What people expect to find is not today's life, but the remains of past life. Because in a way, Mars had like an acceleration of the life of the Earth, and now it's totally inhospitable, but in the past it wasn't.
Okay. Professor, in your words, how important was for Chile to achieve from the international observatories installed in the Atacama Desert the 10% of use of the Chilean institution? How important was?
Oh, extremely important, by all means. And they worked out, I would say honestly, a very good deal. And we all accept it very well. I mean, there's hasn't been discussion now for a long time about this, and we are very happy to see that the astronomical community in Chile is taking advantage of this and is raising and raising and raising, that it has been supported not only by our, because we also support them, not only we give them %, but we give them some money too. But the Chilean government has made a big effort in giving them money as well. So it's one of the communities worldwide that has risen the most and progressed the most in all these years, and they are of course in this extremely privileged position because there are newer and newer instruments arriving. Like now there will even be, in addition to all the optical, and then we have ALMA and all that, now there will be CTA for gamma rays, and every time they get their share. It's
Professor, let me place you in another way. A supernova is a catastrophic explosion of a giant star. You're an expert on that. What is the most fascinating for you? Think about the death of the stars and how this is connected with our life.
So I think what's quite remarkable is that we have known about supernovae since the 1930s, and we have started studying them in detail since the 1980s. And we have the basic ideas. Big star collapses the center, and a process occurs that causes the explosion. We still don't understand that process very well. The other type of supernova, type 1a, is a very small star that becomes unstable and explodes. And it turns out we don't understand that process very well either. So there's still, the fundamental way they explode is still a bit of a mystery. But we do know they do some important things. If you look at the copper and the iron and things that are mined in Australia and in Chile, well, most of that came from these explosions. They create and disperse the elements that allowed Earth to form, life to evolve, and make that rich concoction of atoms that makes life and everything interesting. Without these exploding stars, the universe is just kind of balls of gas that doesn't do much.
So for you, it is very important.
Well, I think it's pretty foundational to understand, humans want to understand our life story. And our life story is part of the story of the universe, and we cannot understand our lives without understanding the story of the universe.
So you agree with the sentence, we are stardust?
We're
Sure.
definitely
We're
stardust.
stardust,
Yes.
yes.
Okay. Professor, how astronomy can make our life better?
Well, all these discoveries that we are making, trying to understand better the universe where we are, seeing that they are also planets around other stars, understanding as much as we can the supernovae, where does the matter that we're made of come from. All that is interesting, I think, for the whole humanity. And what I was saying about we are privileged because we can live thinking a lot about such things rather than everyday contingency. I think that part of this is true for everybody else. My personal experience is that when I meet people to whom we can talk about our results and what we are studying, and they get interested and continue reading and continue asking, they are also happier. It's much, much better and much nicer to do this than to play a game on your telephone, you know? So I think that we are bringing also happiness to the rest of humanity.
For you, Professor?
Modestly.
So I do think it is just central for humans to go out and want to explore, but there's some real practical benefits for humanity. So if you want to motivate young people to go out and learn the maths, the science and things, they don't do it because you throw a fourth-year undergraduate engineering book at them. They do it because when they're 8, they wanted to understand how the world works. They wanted to understand science. So it is part of the motivation to get people to engage with some of the hard stuff, is because the hard math and physics allows you to see beauty in our universe, and it also allows you to build bridges and things. So it's actually a very useful motivating factor. And in the process of trying to solve hard problems, you know, astronomers and the areas around us are very creative. So in the end, you know, in the areas that I work in, we have created amazing inventions as part of the process. So if you look at your mobile phone, and you know, the Wi-Fi in that, well, that's from Australian astronomers who failed to detect Hawking radiation, the evaporation of black holes, but were able to use the techniques to create a way for radio communication at high speeds. If you look at the digital cameras we all have, the CMOS was developed so that we could have a low power way of taking pictures on a trip to Jupiter. And there's a whole bunch of other things that fall out of it. So it's not that you know that you're going to develop those. They happen randomly as part of the process. Because if you only develop things you know about, then you only develop things you know about. You don't get the revolutions. You don't get the internet revolution. It just doesn't happen because the creativity there isn't allowed.
Fascinating.
I think we should add that we're also the kings of big data. You know, big data is becoming such a big topic. Okay. Now, we astronomers have started quite before everybody else, acquiring a lot of data from, say, origin of the sky, different wavelengths, different sizes, this and that, learned how to put together all this data to make it available to everybody in a simple way, to reduce the data, etc. And now, of course, it's become a very hot topic. It's used in everything. And we bring basic knowledge to everybody because of our experience.
And, you know, that's the foundations of my Nobel Prize, was big data back in 1995. Yeah. And I used rudimentary AI back then. And my students, interestingly enough, well, some of them become astronomers, but some of them are working in that field 20 years ago. Yeah. So astronomers contribute, people who don't just do astronomy, but use the thinking about solving astronomical problems to go solve other problems that people and bureaucrats think are useful today.
Well, thank you both. Now we're going to go to the break. Gracias. Bienvenidos nuevamente al programa Encuentros del Futuro, del programa de entrevista del Congreso Futuro. Professors, let me give you a sentence that has, it seems like it's important. The power of failure. How important is to fail in science, in astronomy?
I think not more than in any other human endeavor. You often learn from your failures. One way we can say we fail is there is a phenomenon we haven't yet been able to observe. So we make a theory and we make predictions. And then finally we have at last the telescope, the instrument that can measure that. We go and it doesn't do what we said it would do. Like today, I talked about the existence of very large galaxies with the very large clouds of gas and dust very early in the life of the universe. We didn't expect that. We thought that early on it would be only small galaxies and without dust because the stars had not yet had time to make it. Well, we were wrong. So it's a big surprise, and you can say it's a failure of all your models. You have to go back to them. But at the same time, to be honest, for all of us, it's huge excitement. It's much more interesting when it doesn't do what you planned, and then you have to rethink it. Like you found, of course, the acceleration of the expansion of the universe.
You will look at something different, isn't it?
Yes.
Yeah, so I think there's two modes of failure. So let's talk about the grand failure, where you go out to measure how much the universe is slowing down and discover that the universe is speeding up.
Yes.
Yeah.
So science, as I said in my talk, is all about predicting and being able to predict the future. And when you cannot predict the future, especially when you think you can, that's exciting, because it means you've learned something, or there's something you thought was true that is not. So that version of failure is at the core of scientific progress. But then there's little failures, where you just make mistakes, or where you're doing something that's too hard. And so I always tell my students to think about what they always say in Silicon Valley. You need to fail often, but fail fast. So make your mistakes, realize you make a mistake, and try something new. And we do that every day when we're thinking out what we're going to do next. We do quick little calculations in our head and say, nope, 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 and we move on. So being able to think things very quickly through your head, each one of those is a little failure. You had an idea, but you're able to rule it out, usually in 3 or 4 minutes. We don't think of that as failure, but it's better to do that.
It's part of the process.
It's part of the process, because if you take a year to do that, that really is failure, and life's not so good at accepting that type of failure.
But I still want to add something. There is another kind of failure, and that one is very bad and doesn't help anybody. I'm very much involved in space astrophysics. And the worst kind of failure is if you build an instrument that takes more than 10 years to put on board of a spacecraft, and later either the spacecraft doesn't make it or the instrument doesn't make it. That is absolutely terrible, depressing. I just can find nothing good about it. And this is why, of course, we have a lot of we take a lot of precautions for this to happen as little as possible, and I must say I'm very lucky, because personally it's never happened to me. None of the missions I've been involved in, or none of the instruments I've been involved in, had problems. But I have many friends, in particular, working in exploration. You know, many missions to Mars failed, whether a few American, a lot Russians, etc. And that is really heartbreak.
Absolutely. Professor Cesarsky, you were the first woman in history to become the first president of the International Astronomical Union.
Yes.
What advice can you give to those primary and secondary students that are dreaming with a position like that? How hard was for you to get there?
You mean boys and girls, or only girls? Boys and girls. Well,
perhaps also girls, but
yes,
students in general.
I think we have been expressing it all along. I believe that astronomy is a wonderful field, and if you manage to get a place into it, then you can have an extremely interesting life and fulfilling, and you are bringing something to humanity at what I think the level of knowledge is a very important level in life. So I can only encourage them if they feel they have what it takes to go for it. Now, to have what it takes is something it's better that you find out. If, for instance, you hate mathematics, and you think you can go because you will make nice pictures, and don't go. You need a mathematical basis. You need a physics basis. You cannot do astronomy if you don't understand physics. You cannot just jump to the nice part of it. So what I tell the children who could be interested, at school, do your mathematics, later do your physics, and then you can become an astronomer.
Perfect. Professor, do you have an hypothesis of what is dark energy?
Well, dark energy remains a mystery. In 1998, the best answer we had was something Einstein invented in 1917, which is, we think of it now as energy of the vacuum, we say, or it's energy that is everywhere in space, immovable, it is always there, and it does not change over time or throughout the universe. That can cause, if there's enough of it in the universe to accelerate. That's 70% of the universe required. To date, we have gone through, and we being the entire community has made experiment after experiment. That first hypothesis, the simplest hypothesis, has never been ruled out. So it doesn't mean it's correct, but science is always the simplest hypothesis that works, is the one you use, and you keep testing it, and whether or not it's true or not is sort of, you want to try to find out the underlying truth. But if you can't show something is wrong, then you're kind of stuck. And that's where we are with dark energy right now. We're kind of stuck.
Because we would like the explanation to be different.
Yes.
I think you also have to say that. The simple explanation seems to work, and we don't like it. Physically, it's not pleasing. So we are hoping to find something else.
What is the next step?
So what we have been doing is we've been basically improving the experiments one way or another that we did in 1998. And as we improve them, we keep on getting essentially the same answer, just with smaller and smaller uncertainties. So that is the only way people have figured out how to make progress at this point. So I actually think we need a theorist, not someone who goes out and measures things, but someone who has an idea of something we could measure that is different than what we have done thus far. That's the breakthrough I think we need. And we won't, there was 300 years between gravity and Einstein, gravity by Newton and Einstein, or 250. It could take a long time, or maybe it could happen tomorrow. You just don't know.
There are many more researchers today. I agree completely with you. We need another Einstein. On the other hand, the pool is so much bigger that maybe we will have to wait as long as all that. But meanwhile, there are many ways to test whether this simple explanation works, with more and more details. So there are telescopes that will be devoted to doing experiments related to that, and one in Chile in particular, LSST, in preparation. And there are also space missions being thought. The Europeans are constructing one called Euclid, and the Americans are planning one for later that will narrow down again the error of this agreement with Einstein, and as I said, with the hope of finding something different.
We have a new generation of telescopes coming soon. Some of them, and most of them, seems to be that they will part of the Atacama Desert. EELT, it seems like it's one of your sons.
Yes.
Can you tell me a little bit
My babies.
what we will be able to see with that machine?
Well, on faraway galaxies, we'll be able to see, because it will be much more sensitive. Why do we want big telescopes? The stars, the planets, and of course, in the same way, galaxies, faraway galaxies, are emitting light in all directions. So if you go with a small telescope, you just catch this part of the light. You put a big telescope, you catch a lot more. So definitely you are more sensitive, and you can either see further, or see the fainter objects, or see the details. And so we are going to be able to see a lot of details. What type of stars are inside faraway galaxies, more clearly where do stars form. We will be able to see supernova in galaxies further and further away and follow them. And in the case of extrasolar planets, we will be able to look at the atmospheres of perhaps some exoplanets that are what we call super-Earths, somewhat bigger than the Earth.
Perfect. And Professor, this is the last question. How your life changed after winning the Nobel Prize? What do you miss of your past life?
Well, winning a Nobel Prize, you don't know what's coming. They just call you up one day and they say,
by phone?
congratulations, you have won the Nobel Prize, and in my case, we're telling the world about it in 6 minutes. And for people who are my friends and my family, it's excitement, but I'm still Brian. They know what I'm good at, and they know what I'm bad at. So that hasn't actually changed very much. The thing that changes is that people who meet me after the Nobel Prize think I'm more of a Superman than I really am. And they comes with certain expectations. On the positive side, it gives me the opportunity to go out and do and have a voice for good to help, do everything from issues of understanding climate change to the ethics of understanding how we use CRISPR and Cas9 in the biological system, and being able to sit down as a reasonably sensible person and help society use all this knowledge to bring better prosperity. So that's a huge opportunity that I get that I did not have before the Nobel Prize. But it comes with the cost that you're always at the center of things that are not necessarily your expertise, and your ability to just sit down and focus on one thing, which is what I did my entire career, that has been taken away.
Thank you, Professor, to both of you. Muchas gracias a todos. Nos vemos.